Next definition is definition of modulus. Let z is equal to x plus yi or x plus iy be a complex number. The modulus or absolute value of z is denoted by this notation, mod z. This is the notation for modulus, or it's called absolute value. Mod z, read it as mod z, is defined to be plus root of x square plus y square. Root x square plus y square. Take plus value. That is if root we have the x square plus y square is 16, suppose root 16. So actually the value of root 16 is what? Plus 16 and minus 16. So don't take minus 16, take plus 16 as a value of this root 16. And that is modulus is always positive. So it is what? Mod z is what? Root x square plus y square. That is square of real part plus square of imaginary part. And then what is the, if z is 2 minus 3i or 2 minus 3i, or in order pair 2 comma minus 3, both are same. That is the writing styles are different. That is this 2 minus 3 and this 2 minus 3i, both are same complex number. Then what is mod z? Root this 2 square and this minus 3 square is root 13. So if both are negative, then the squares are also positive, x square, y square. And so if you find modulus of minus 2 plus 3i, then it is again root 13. If you find modulus of minus 2 minus 3i, then again it is root 13. And if you find modulus of 2 plus 3i, then it is again 13. So modulus of these four numbers, what are that? 2 minus 3i, 2 plus 3i, minus 2 plus 3i, and minus 2 minus 3i, all are same, because x square plus y square, that is a square of negative, is again positive. So this is the definition of modulus, or is called absolute value of the complex number z. So z is suppose this complex number, then mod z is always greater than or equal to 0. And mod z is 0 if and only 0 z is 0. If z is 0 means x is 0 as well as y is 0. That is, if z is 0 means 0 plus 0i, that is real part and imaginary part, both are 0, then its modulus is 0. And z bar is x minus yi, is conjugate. And what is mod z bar is again root x square plus minus y square. And what is the modulus of z is x square root x square plus y square. That is mod z and z both are same. That is modulus of conjugate and modulus of itself, both are same. This is important, that mod z bar and mod z both are same. Then z into z bar, z is this, z bar is this. It is what? X square plus y square. That is mod z square. And this is very important concept, that mod z square is what? Z into z bar. Because z into z bar is x square plus y square. And what is x square plus y square? Is mod z square. Mod z is root x square plus y square. Mod z is, and its square is what? X square plus y square. And so mod z square is z into z bar. And mod z is this real, that is the root real part of z square plus imaginary part of z by square. Okay. And that is therefore mod z is always greater than or equal to real part of z, and mod z is always greater than or equal to imaginary part of z, because both are positive quantity, real part of z square and real part of imaginary part of z square. That is, these two are same if imaginary part is 0, and these two are same, is mod z and imaginary part of z are same if real part is 0. Okay, so next definition is definition of argument of complex number. Z is equal to, in format of order pair, x y or x plus yi, be a complex number. Then argument, or is called amplitude of z, is defined to be an angle theta measured in radian. That is the angle. Argument is the angle measured in radian, such that theta is tan inverse y by x. So this is the definition of argument. What is the argument of the complex number x plus yi? Is tan inverse y by x. So this is the, which is determined up to multiplies of 2 pi. Okay. So the unique value of theta determined by tan inverse y by x, such that theta lies between minus pi to pi. Actually, this is open close interval here. In this side close, it is minus pi to plus phi. So up to pi, right here, close interval, one side close, is called a principal argument. So this is the principal argument. So what is the notation for principal argument? ARGZ, that is read it as argument of Z, or called principal argument of Z. And what is the definition of principal of argument of Z? Tan inverse y by x minus pi. Tan inverse y by x is lies between minus pi to pi. Okay. So what is the definition of principal argument or argument of Z? Is tan inverse y by x, and this tan inverse y by x lies between minus 180 to 180. That is strictly less than minus 40, and it is equal to or less than 180. Okay, pi means 180. Okay, so the value lies between this argument is called principal argument. So for principal argument, theta is tan inverse y by x and y are greater than or equal to 0. X and y are greater than or equal to 0. Then use this definition. Theta is what? Tan inverse y by x. Theta, that is principal argument, is tan inverse y by x if x and y both are greater than 0. That is the numbers, real part and imaginary part both are greater than 0. Then use this definition. Is equal to minus tan inverse y by x if x is greater than 0, real part is greater than 0, and imaginary part is less than 0. Then use this definition, minus tan inverse y by x. This is actually this is the definition, but in purpose of solving example, use this definition. There are 4 definitions. That is, if the number lies in the first quadrant, if x and y are both are positive, means lies in the first quadrant, then use this definition. If x is greater than 0 and y is less than 0, means the number lies in the fourth quadrant. X is greater than 0 and y is less than 0. Okay. So if the real part is greater than 0, imaginary part is less than 0, then use theta as minus tan inverse mod y by x. Mod y by x. That is, take positive number y by x. Then if x is less than 0 and y is greater than 0, that is, x is less than 0 and y is greater than 0 means second quadrant. Then use the definition theta is equal to, that is principal argument, pi minus tan inverse mod y by x. And if both are negative, x and y both are negative, then use the definition theta as tan inverse mod y by x minus pi. Here pi minus tan inverse mod y by x. Here tan inverse y by mod y by x minus pi. So use these 4 definitions. This is for the first quadrant. This is for the fourth quadrant. This is for the second quadrant. This is for the third quadrant. Both are negative. So if we observe the figure, so Argon diagram. So if the number lies in the first quadrant, yeah, then both x and y are positive. X and y both are positive. That is real part and imaginary part. When this the number lies in this quadrant, second quadrant, then x is negative and y is positive. And if the number lies in the third quadrant, then x and y both are, that is real part and imaginary part both are negative. And if the number lies in the fourth quadrant, then its x part is x coordinate, that is the real part is greater than 0 and imaginary part is less than 0. And actually the tan inverse y by this angle is if you find argument of this 2 plus 3i, then geometrically what is the argument of 2 plus 3i? The angle made by this line, suppose this point is P, OP, with x, positive x axis. This is the argument, geometrical meaning of the argument. The angle made by the line with positive x axis. So if the number lies in the first quadrant, then its argument, principal argument, lies between 0 to 90. If the number lies in the second quadrant, then its principal argument is greater than 90 and less than 180. If the number lies in the third quadrant, then it's principal. Suppose this is the line joining the number with this origin. Then it's this angle becomes greater than 180, and we have to find principal argument. So we measure this angle, and this angle is the principal argument. Actually, it is negative. Then if the number lies in the fourth quadrant, so if the number lies in the third quadrant, complex number lies in the third quadrant, then its principal argument is lies between minus pi to minus pi by. And if the number lies in the fourth quadrant, then its argument is lies between 0 to minus pi to 0. Okay, 0 to minus 180 or minus 180 to 0. Here minus 180, not minus 180, minus 90 to 0 if the number lies in the fourth quadrant. And if the number lies in the third quadrant, then its argument lies between minus 180 and minus 90. Okay, so here are the four definitions. Actually, these definitions for problem. These definitions for problem. Actually, if we have to write the definition of argument, then write just argument of z. Suppose z is x plus yi, then argument of z is tan inverse y by x. So this is the definition. And tan inverse y by x less than equal to pi by 2, less than equal to pi, and greater than minus pi. This is the definition of argument of principal argument. Okay, so a complex number xy is order pair real number. It is may be represented geometrically by a point in the plane. Okay, so this is the point order pair xy or x plus yi complex number. Then we can represent it by this point, and if we join this point P with the origin, then this is what is its modulus. So what is the geometrical meaning of modulus? The distance of the point P, that is xy, from origin is the modulus, is the modulus, and the angle made by the line with positive x-axis is called its argument. So these are the geometrical meaning. So it's shown in the figure. In this context, the xy plane is often referred to as a complex plane. This is the complex plane or argument plane, and x-axis is called real axis, y-axis is called imaginary axis. So in figure, the complex number minus 2 plus I is this number, because real part is negative, imaginary part is positive. 2i, this is the number 2i. 1 minus 2i, this is 1 minus 2i, because real part is 1 and imaginary part is minus 2. So it is lies in the fourth quarter. So these are the numbers. And if we have to find the modulus and argument geometrically, then this is the distance of the point from origin is the modulus, and the line made the angle with positive axis is called argument. So x is r cos theta, y is r sin theta, and z is equal to x plus y. So here, if this angle is theta, then what we have? We have this distance is y and this distance is x, because this point is xy. Okay, and so what is cos theta? Cos theta is adjacent side, that is x divided by r, this modulus. Okay, so x is what? Cos theta is x by r, means x is r cos theta, that is this x is r cos theta. And what is sin theta? Sin theta is opposite side, that is y, opposite side, y divided by r hypotenuse. Okay, this is the right angle triangle. So r. So sin theta is y by r, and therefore y is r sin theta, x and y. So if you substitute this x and y as r cos theta and r sin theta, then we have z is equal to r in bracket cos theta plus I sin theta. Take r this common factor. Then r is root x square plus y square, and theta is tan inverse y by x. Okay, so this r is equal to z is equal to r cos theta plus I sin theta is the another form of the same number x plus yi or x plus iy, and this is called polar form of z. This form is called coordinate form. This is the coordinate form, the polar, and this is the polar form. This is the polar form of the number z. That if we write z in this form, r in bracket cos theta plus I sin theta, where r is what? Modulus of that number, and theta is its principal argument, then this z in this form is called polar form of z. So It is clear from the above discussion that the polar form of the complex number is what? Z is equal to R in bracket cos theta plus I sin theta, where R is what? Modulus of Z, and theta is argument of Z. So in order to express the number, complex number in polar form, we have to find first its modulus and argument, principal argument. If we find R, value of R and theta, then we can express the complex number in polar form. So in order to express the number in polar form, complex number in polar form, find its modulus and argument, principal argument. Then we have the number in polar form. So, and if we write this is in this form, is called exponential form. Z is equal to R e raised to I theta. We know that what is value of e raised to I theta? E raised to I theta is cos theta plus I sin theta. E raised to I theta, exponential function. So e raised to I theta is what? Cos theta plus I sin theta. This is exponential form of the complex number Z. This is the polar form. This is the exponential form of the complex number. So express the given complex numbers in polar form. 1 minus 1 minus I minus I, 1 plus I, 1 minus I, 1 minus 1 plus I, minus 1 minus I. That is where to find the modulus and arguments of these numbers. So first is 1. So use these definitions to find the modulus, that is value of R. Use the definition root x square plus y square, and to find the principal argument, use this definition. So what are the x and y? That's dependent. So first is 1. We find first 1 plus I, modulus and argument of 1 plus I. So in the coordinate form, it is 1, 1. In the xy order pair form, it is 1, 1. Actually, the number 1, 1. And so what is R? R is modulus of that number is root 1 square plus 1 square. By using this formula, R is what? Mod Z, that is root x square plus y square. X is 1, y is 1. That is root 2. Modulus is root 2. And what is the principal argument of that number? This 1 plus I. So use the first definition, this definition. Theta is equal to, because both x and y are greater than 0. So what is theta? Tan inverse 1 by 1. That is tan inverse 1. And tan inverse 1 is what? Pi by 4. So principal argument is what? Is pi by 4. And therefore its exponential form is what? Root 2 e raised to pi by 4i. Pi by 4i. That is, this is the exponential form. R into e raised to I theta. R is root 2, theta is pi by 4. So e raised to root 2 e raised to pi by 4i, or pi I by 4. Okay. So this is the exponential form. Then 1 minus I. So again, the number in the order pair form is what? 1 minus 1. Order pair 1 minus 1. Then it is its modulus is what? R is what? Modulus of the number is what? Root 2. Again, 1 square, x square. 1 square is 1, and y square means y is minus 1. Its square is again plus 1. So root 2. So 1 plus I, 1 minus I, minus 1 plus I, minus 1 minus I. Arguments are same. Not argument. Modulus are same. Because x and y, root of x, x square and y square. X and y are positive or negative, but x square and y square are always positive. So this is the modulus, that is value of R, root 2. And then argument, we have to find the value of theta, that is principal argument. So what is x? X is greater than 0 and y is less than 0. So use this definition. Okay, for theta, use this definition. Minus tan inverse. So write minus sign, tan inverse mod y by x. So y is minus 1 and x is plus 1. So minus 1 plus 1 divided by plus 1 is minus 1 actually. The division is minus 1, but mod of minus 1 is plus 1. And then tan inverse 1 is what? Pi by 4. So minus tan inverse 1, that is minus pi by 4 is the argument, principal argument of this number. And then the number in the form of polar form, exponential form is root 2 e raised to not this 3 pi by 4 right here, minus pi by 4i right here. This answer. This is the answer of the previous. This right root 2 e raised to minus 5 pi by 4 at this place. Right? This is at this place. Okay. So this is the answer of this problem. 1 minus I. Its exponential form is what? Root 2 e raised to minus pi by 4i. So right here, this answer above and this answer below. Then minus 1 plus I. It's modulus and argument. This is the coordinate form in the order pair form. Minus 1 plus 2. Okay. And then modulus is what? Modulus root x square plus y square. That is minus 1 square plus 1 square is root 2. And then here x is negative. X is negative. Real part is negative. And imaginary part y is positive. So use this definition. Theta is equal to pi minus tan inverse y by x. So mod y by x. Pi minus tan inverse. So what is theta for this? Is pi minus tan inverse y is plus 1 divided by x is minus 1. So 1 by minus 1 is minus 1, but its modulus is plus 1, and tan inverse 1 is pi by 4, because tan of pi by 4 is 1. Tan of pi by 4 is 1. So tan inverse pi by 4 is tan inverse 1 is pi by 4. So pi minus pi by 4. So what is the answer? Tan inverse mod y by x. So we have the answer pi minus pi by 4. So 4 is the LCM and 4 minus pi. So don't write here minus pi. Remove this minus pi. Remove this minus pi. Just write pi by 4. So pi minus pi by 4. 4 is the LCM. 4 pi minus pi is 3 pi. So don't write here minus pi. So tan inverse y by x, that is tan inverse 1 is pi by 4. Just write pi by 4. Remove this minus sign, So pi minus pi by 4 is 3 pi by 4. So this is the principal argument of this minus 1 plus I. This answer. Okay. And therefore its polar form is this root 2 e raised to 3 pi I by 4. Right here. This answer at this place. So root 2 e raised to 3 pi by 4 I. This is the exponential form. Then last number, this minus 1 minus I. Both are negative. Real part and imaginary part both are negative. So use this definition. Pi tan inverse y by x. So again modulus is root 2. Root minus 1 square plus minus 1 square is root 2. And then pi, this value of tan inverse y by x. So what is y? Y is minus 1. Y is minus 1. X is also minus 1. Minus 1 by minus 1 is plus 1. And its modulus is plus 1. And tan inverse 1 is pi by 4. Minus pi is minus pi. And then answer is what? 4 is the LCM. Pi minus 4 pi, that is minus 3 pi by 4. And then its exponential form is what? Root 2 e raised to minus 3 pi I by 4. So this number lies in the fourth quadrant. Okay. So these are the formulas to determine the principal argument. Actually, in the example, for example purpose, use this formula. If we ask the definition of principal argument, just write argument of z is equal to tan inverse y by x, and this tan inverse y by x lies in the lies between minus pi and pi. Okay, this is the definition of principal argument. But in order to find the actual principal argument, then use these four formulas. Okay, so use the first formula, tan inverse y by x, both are positive. This is used if x is greater than 0 and y is less than 0. Use this formula. If x is less than 0 and y is greater than 0. Use this formula if both are negative. Okay. So we have to find the modulus and argument of one number. One is also a complex number. We can write 1 as 1 plus 0i. So 1 0 is its polar form. It's order pair form, coordinate form. Order pair, in the order pair form, 1 plus 0i. 1 means 1 plus 0i. And then its modulus is what? R is what? Root x square, that is 1 square plus 0 square, that is root 1, that is 1 is it's a modulus. And principal argument. And what is the principal argument? Both are positive. So use this definition. Theta is tan inverse 1 y0, 0 by 1. 0 by 1 is what? 0, and tan inverse 0 is 0. Tan inverse 0 is 0 because tan 0 is 0. Okay, and therefore its exponential form is 1 into e raised to 0 I. 1 into e raised to 0 I. It's polar form. It's an exponential form. And if I have to write, suppose the polar form of this number 1 plus I, then what is its polar form? The polar form is what? Here, write one more column, polar form. Then what are the polar form? Root 2 in bracket cos pi by 4 plus I sin pi by 4. So write the polar form in this form. R is root 2 in bracket cos pi by 4 plus I sin pi by 4. So write polar form, answer in the polar form 1 plus I. So here this is the exponential form. Draw one more column here, and write polar form. So write polar form of each. So what is the polar form of this number? 1 minus 1 plus I root 2 in bracket cos pi by 4 plus I sin pi by 4. What is the polar form of this number? Root 2 in bracket cos minus pi by 4 plus I sin minus pi by 4. Okay, what is the polar form of this number? Root 2 in bracket cos 3 pi by 4 plus I sin 3 pi by 4. Similarly, right? What is the polar form of this number? 1 in bracket cos 0 plus I sin 0. Okay, so write polar form of each number. Then minus 1. The minus 1 number is what? Minus 1 plus 0 I. Minus 1, 0. It's in order pair form. Then 1 is its modulus. Again, root minus 1 square plus 0 square. Root x square plus y square is 1. Root 1, that's 1. And what is its principal argument? Use the formula that x is negative, and y is positive. So use this formula. Theta is pi minus tan inverse y by x. That is y is actually 0, but if it is equal to greater than 0 or equal to 0. Y is not negative actually. Y is not negative. X is negative. Y is not negative. So here is non-zero, greater than or equal to 0. Y is greater than or equal to 0. So minus 1 by 0. What is y? Y is 0. So 0 divided by minus 1. 0 by minus 1 is 0. And tan inverse 0 is 0. Pi minus 0, that is pi. So the principal argument is pi. Pi minus tan inverse 0. So some 0 divided by something is 0. But 1 by 0 is infinity. Something by 0 is infinity. So the next problem is what? I is, you can write I in the form of 0 plus 1i. Don't write here this form. 0 plus 1i. That is real part is 0 and imaginary part is 1. 0 plus I. So right here 0 plus I. Don't write I plus 0. 0 plus I. 0 plus 1i. That is 0 is its real part, 1 is its imaginary part. And then its modulus is what? Root 0 square plus 1 square. That is root 1. That is 1. And its principal argument. The formula is what? Both are positive, x and y are positive. So use this formula. Tan inverse y is 1 and x is 0. So tan inverse 1 by 0. Tan inverse 1 by 0 is tan inverse infinity. And tan inverse infinity is pi by 2 because tan pi by 2 is infinity. So tan inverse infinity is pi by 2. So we have the answer pi by 2. This is the exponential form. And what is the polar form? 1 in bracket cos pi by 2 plus I sin pi by 2 is its polar form. Then minus I. Minus I is number 0 minus 1i. 0 plus minus 1i. So 0 is real part, minus 1 is imaginary part. 1 is its modulus and argument. Its argument is what? Principal argument of this number is what? The x part is non-negative, 0. and y part is negative. So y is negative and x is non-negative. So use this formula. Minus this number, for this number 0 minus 1 minus tan inverse y is minus 1, x is 0. So mod of minus 1 by 0 is 1 by 0 actually, that is infinity, positive infinity, and tan inverse infinity is pi by 2. So minus pi by 2 is its modulus, is its argument, principal argument, and therefore its exponential form is this, and its polar form is what? 1 in bracket square bracket cos in bracket minus pi by 2 plus I sine minus pi by 2 in bracket. Okay, so these are the modulus and arguments of the some numbers. So here is the question: express the minus 1 plus I in polar form. So use these formulas, or use the formula that is the modulus is actually r is root 2 root x square plus y square, x is minus 1, y is plus 1. Don't use this method that cos theta and sin theta. Just write theta is equal to, what is the theta? X is negative, y is positive. X is negative, y is positive. So use this formula. X is negative. Theta is equal to pi minus tan inverse y by x. I substitute y and x. That is minus 1 plus I. Actually, here what is the its argument? Principal argument 3 pi by 4. So there the answer 3 pi by 4. Don't use this method. Use this method. Use these formulas. This formula for minus 1 plus I polar form. Okay, and so its polar form minus 1 plus I, its polar form is what? Root 2, right in bracket, cos 3 pi by 4 plus I sine 3 pi square bracket. So this is the polar form. So draw here one more column and write the polar form of all the numbers like this. Like this. This is the polar form. So draw one more column while writing notes in your notebook. Draw one more column here and write the polar form of each complex number. So this is the polar form of minus 1 plus I. Then we have to find the polar form of this, or we have to find the modulus and argument, principal argument. In order to find polar form, we have to find modulus and principal argument. So the question is what? Find modulus and principal argument, or the another question is what? Find the polar form or find exponential form. So in order to find polar form or exponential form, we have to find modulus and principal argument. So the questions are different, but the answer are same. That is, find modulus and principal argument, or find polar form, or find exponential form. So first find its modulus and argument. So modulus is what? Modulus Z is what? Root x square plus y square. X is minus 3, and root 3 minus 3 square is 9. Root 3 square is 3. So root 12, that is 2 root 3. 2 root 3 is its modulus, and that is the value of r. And we have to find the principal argument. So the formula is what? Tan inverse y by x, because both are positive. No, though both are not positive. So here use the formula. X is minus 3. So negative, x is negative, and y. So use this formula. Pi minus tan inverse mod y by x. Instead of this tan inverse y by x, use the formula tan inverse mod y by x. Then we get the answer 150 degree. 150 degree. 150 degree in radian. Right? 150 degree in radian. What is it? 150 means 90 plus 60. That is pi by 2 plus pi by 6. 6 is the LCM. Then 8 pi by 6. That is 4 pi by 3. Okay. Pi by 90 means pi by 2 plus pi by 3. 60 means what? Pi by 3. So 60 is the LCM. 3 into 2, 6 is the LCM. And then 5 pi by 6. 5 pi by 6 is in radian, tan inverse. So don't use this method. Write this formula that theta is pi minus tan inverse mod y by x. And then write mod y by x. Mod y by x is what? Mod tan inverse 1 by root 3. tan inverse 1 by root 3. Use the table and write tan inverse 1 by root 3. It is 30. Tan inverse 1 by root 3 is 30. So 180 minus 30, we have the answer 150. Okay. So don't use this method. We get the answer 150 degree. Complete modulus and principal argument of each of the following number. I raised to 7 plus I raised to 10. So what is I square? I square is minus 1. What is I cube? I cube is I square into I. That is minus 1 into I is minus I. I raised to 4 is what? I square into I square. That is minus 1 into minus 1 plus 1. I raised to 5 is what? I raised to 5 is I square into I square into I. That is minus 1 into minus 1 into plus 1 plus I is I. Then similarly, I raised to 7 is what? I raised to 4 into I raised to 3. I raised to 4 is a minus is plus 1 and I cube is minus I. So I raised to 4 into I raised to 7. But the right I raised to 7 and I square into I square into I square into I. There is minus 1 into minus 1 into minus 1 into I. That is we have the value is minus I. Then I raised to 10 is what? I square into I square into I square 5 times. That is minus 1 into minus 1 into minus 1 5 times. That is minus 1. So value of I raised to 10 is minus 1. And the value of I raised to 7 is minus I. So this is the number minus 1 minus I. And what are its argument and principal argument and what is its modulus? We know that. So minus 1 minus I, its modulus is root 2 and principal argument is minus 3 pi by 4. But use this method. Don't use this method. That find a principal argument by using that formula. That formula is what? Right here formula. Both are negative. Therefore, tan inverse mod y by x minus pi. Here write the formula. That formula. That tan inverse. Don't write this formula. Argument of that number is what? Tan inverse y by x mod y by x minus pi. So we have the answer minus 3 by 4. So then we have to find the principal argument and modulus of this number 1 by 1 plus I. So express first this number 1 by 1 plus I in the form x plus yi. X plus yi. In order to that, find this division. And if I have to find the division of two complex number, rationalize denominator 1 minus I. Multiply by 1 minus I and divide by 1 minus I. Then 1 plus I, 1 minus I becomes 1 plus 1. Because I square is minus 1, then 1 half, then this is 1 minus I, then 1 by 2 minus 1 by 2 I. This is the standard form of the complex number x plus iy. X is 1 by 2, y is minus 1 by 2. And then modulus is what? Root x square plus y square. That is 1 by root 2 is the modulus and principal argument. So this number x is positive, y is negative. X is positive, y is negative. So use this formula. X is positive, y is negative. Minus tan inverse mod y by x. So right, y and x, y as a minus half, x as half, and then minus half by half is 1, and tan inverse mod minus, actually minus 1, but its mod is plus 1, and tan inverse 1 is pi by 4. So minus pi by 4 is the answer. Don't use this method. Use right here the formula, this formula, tan inverse mod y by x minus pi. We get answer minus pi by 4. So convert all these problem in that form. Then third number is minus 1 plus I raised to 3. So first find its third power. So x plus y raised to 3. That is x square, x cube, x plus y raised to 3 is x cube plus 3x square y plus 3xy square plus y cube. So by using that formula, we have this answer. I cube is minus I square is minus 1. So we have this answer 2 plus root 2 plus 2i. Then its modulus is what? Root x square, 2 square plus 2 square, that is root x. And principal argument, both are positive. So use formula tan inverse y by x, 2 by 2. That is tan inverse 1 is pi by 4. So its argument is pi by 4. Okay. So if we have to write the polar form of this number, then write it is root 2 this z is equal to root a in bracket cos pi by 4 plus I sin pi by 4. Then last number, this is 1 plus I cube. This problem, 1 plus I cube by 1 minus I square. First find 1 plus I cube and then find 1 minus I square. This is 1 minus I square. X minus y square is what? X square minus 2 times x into y plus y square. So we have this answer, minus 2 plus 2i divided by minus 2. So in order to express this number in polar form, multiply by plus 2i divided by plus 2i, or just multiply by I and I, divide and multiply by I. This is the this is the conjugate of this number actually. uh, so rationalizing factor, okay, or minus 2 plus 2i plus divide by plus 2i and multiply by 2i. We have the same answer, 1 plus I. And what is the argument and modulus of this number? We know root 2 and pi by 4 are modulus and argument of that number. And if we write in a polar form, then write root 2 in bracket cos pi by 4 plus I sin pi by 4. So these are some, again, the same table, that is the polar form of this. One is cos 0 plus I sin 0, 1 in bracket minus 1 I minus I. That is the same problem, these problems. 1 minus 1 I and minus I, their polar forms. Their polar forms are this. These are the polar forms. 1 minus I, minus 1 minus I, all these. 3 plus, these are the polar exponential form. If the number is a plus bi, then it's polar form, and it's exponential form and polar form. Okay, 3 plus 3 root 3. This is the pi by 3 is its argument, principal argument, and 6 is its modulus. So use the formula to obtain modulus as root x square plus y square. 3 square 9, and 3 into root 3 square is 9 into 3, that is 27 plus 3. 36, root 36 is 6 is its modulus, and argument is what? Both are positive, so tan inverse y by x, 3 root 3 by 3, that is root 3, tan inverse root 3 is pi by 3. So similarly 5 minus 5 means this is the number minus 5 plus 0i, minus 5 plus 0i. So use the formula to obtain the principal argument and modulus. 7i means 0 plus 7i. Okay, 0 plus 7i. Then find it. Its principal argument is pi by 2, and 7 is its modulus. So these are again some problems of finding modulus and principal argument of the number. So what is the problem? First problem is z plus I divided by z minus I. So first express the number z plus I divided by z minus I. What is z? Z is what? If z is 1 minus I, there are two problems. If z is 1 minus I, so substitute z as 1 minus I, and 1 divided by 1 minus 2i. We have to find this division, means multiply by its rationalizing factor, or 1 plus 2i divided by 1 plus 2i. That is rationalization. Okay, and then we have this answer, 1 by 5 plus 2 by 5i. This is the number in the form x plus yi. And then you find its modulus, find its argument. Both are positive, so tan inverse this, tan inverse 2, and tan inverse 2 is not a standard angle. We cannot write it in the radian form. Then use calculator. Tan inverse 2, we have the answer 63.43, or remain as it is, tan inverse 2. Don't write its value by using calculator, or if you have to write its value by using calculator, then use the convert the calculator in radian, then tan inverse 2 is 63.43. Similarly, this number, if we take z as 2 plus 3i here, z as 2 plus 3i, then 2 plus 3i plus I, 2 plus 3i minus I, its calculation is this, and then its modulus is root 10 by 2, and it's a principal argument. Both are positive, so tan inverse just 1 half y by x. So tan inverse 1 by 3, remain it is as it is, or use calculator. We have the answer 18.43 degree. So this is the important theorem on the modulus and argument. We will see in the next lecture.